Hello everyone, so in this video we are going to solve a question of LeetCode, that is partition list. So let's start with the problem statement. Given the head of a linked list and a value x, partition it such that all the nodes less than x come before nodes greater than or equal to x, right? And you should preserve the original relative order of the nodes in each of the two partitions. Right, so basically we have given a linked list and a value of x, and we need to partition this linked list based on this value, right? So let's see the first example. So in the first example we have 1, then we have 4, then we have 3, then we have 2, then we have 5, then we have 2. Right, so this is our given linked list. Now what we need to do is we need to partition this linked list based on the value of x, right? So the value of x is equal to 3, right? The value of x is equal to 3. So what does it mean, right? So the meaning of x value is that we need to partition the linked list based on the value of x such that all the elements which are less than x must be on the left side, and all the elements which are equal to or greater than the x must be on the right side, right? So let's see how can we do this, and before that let's see the first example. So the first example is this one, and after performing this rule, right, this rule of x, we will be converting this linked list to, let's say we have 1 which is less than 3, then we have 2 which is less than 3, and again we have 2 which is less than 3, right? So for this what we can do is, first we can take 1, then 2, then 2, right? This is on the left side. Now we have all the elements which are greater than or equal to x, so we will just write all the elements on the right side. So 4, 3 and 1, right? Since we need to preserve the relative order of the linked list, that's why we should write this into a sequence, right? So this is the answer linked list, or we can say with this list we need to return from here, right? So let's see how can we approach this question, right? I hope this example is clear to you. Let's see how can we approach the question. So to approach the question, we can easily see this, that this list is the one type of linked list, and this is the another type of list, right? These are the two lists based on the value of x, right? This is the first linked list is the left part which is less than 3, and the second linked list is the right part which is greater than equal to 3. So why not to create two linked lists first, right? So what we can do is we can create two linked lists. First one is the L1 and second is the L2, right? So let's see how can we create this. So let's say we take two linked list L1 and L2, right? And initially we put two nodes, that is 0 here and 0 here, right? Now we just iterate through the original linked list, right? So while iterating through the original linked list, we will check all the elements which are less than equal to or greater than equal to x, right? So let's say this one is less than 3, so we will put this into our first linked list, right? Now the second element is 4, so 4 is greater than 3, so we will be putting this into the second linked list, right? Now 3 is greater than equal to x, so for this we will be putting into the second linked list, because second linked list is basically representing the right linked list, right? So we will be pushing this into the second linked list. Now 2, right? For 2 we have, it is less than 3, so we will just push this into the first linked list. Now we have 5, right? The 5 is greater than 3, so we will just push this into the second linked list. And at the end we have 2, so 2 is less than x, right? It is less than 3, so we will just push this into the first linked list, right? So we have just completed the iteration of our original linked list. Now what we need to do is we need to just add these link list, right? Or we need to link both the link list. So for this what we can do is, what we need to do is, let's see, this is the link list, right? This is L1 and L2. So for this we just need to link this 2 to 4, right? We just need to link this, and this 5 next must be null, right? These two steps we need to perform, and we will be just we will be just returning this node, right? This is the head node of the updated linked list, like because this linked list will start from 1, and since this is already linked to 4, so this will go till null, right? So this is the original linked list, or the resultant linked list which we will get after performing this into the original linked list, right? So this is the resultant linked list, and we will just return the L1 dot next, right? L1 dot next, because it is the head of the resultant linked list or the answer linked list, right? So let's quickly code it up. I hope the approach is clear to you. If you still have any doubt in this approach, feel free to comment it down. I will try to explain it again. Let's move to the coding part. So in the coding part, let's first initialize two nodes. It is list node. Let's name it node 1 0 and node 2 0, right? These are the two nodes initially. Now let's point, or we can say these are two linked lists. So let's name it L1 and second one is a L2, right? These are two linked lists. Now we are just traversing through both the linked list and adding the elements, right? So initially we have 0 and 0 in the linked list. So let's point two pointers here. So list node, let's point P1 to L1. So P1 is equal to L1 and P2 is equal to L2, right? These two pointers will help us to add elements into our linked list, right? So now let's traverse to the original linked list. So while head, right? Now let's check if, right, if head value, if the value of the head, right, if this value, right, this value is greater than or equal to 3, right? If it is, head value is greater than or equal to 3, equal to 3, so 3 is basically x, right? So if it is greater than equal to 3, then what we need to do is, right, what we need to do is we need to just add this into the p1 next, right? So p1 next, it should be, then this is the greater one, so this is the L2 one, right? So this should be p2 next is equal to head, and let's update p2 to p2 next, right? And also write the other condition else, right? In the else, this head value, right, head value must be less than x. So for this we will add this into the p1. So p1 next is equal to head, and p1 is equal to p1 next, right? So this will just create both the linked list as this one, right? Now what we need to do is we need to link both the linked list, right? So to link both the linked list, first we will add this null here, right? So let me write the same here. So this p2 next is equal to null, right? And this p1 next, right? This p1 next must be equal to L2 next, right? So this p1 next is equal to L2 dot next, right? I hope this is fine, and at the end just return L1 dot next, right? This is the head, so at the end just return L1 next, right? I hope this should work fine. Let's try to run this on the sample test cases. Yeah, it's yeah, should fine now. Oops, we did a mistake here, that's why it is taking TLE. We just forget to update the head, so head will be head next, right? Because in the each iteration we will be going to the next node, so this is head next. This should work fine now. Yeah, it's working fine. So let's try to submit this. Alright, it's working fine. So the time complexity of this solution is bigger of n, because we are traversing through all the n nodes of the linked list, and its space complexity is bigger of 1, because we are just storing the constant pointers here. So I hope the approach and solution is clear to you. If you still have any doubt in this question, feel free to comment it down. Please like this video and subscribe to our channel. I will see you in the next video.